So here's a really cool trick that'll help you modify the rotation of these pieces once they've been simmed. Go ahead and create a point wrangle, and we're going to multiply against the orient attribute. But we're going to do so in a way that's a little bit weird. So create a vector 4 that's called orient mults, and use a channel vector parameter to only affect the first 3 values of that orient mults. So we'll call this our orient underscore mults right there. And then we say at orient times equals orient mults. And now we have this. So if I go forward, nothing will happen. So 0 means that no rotation will ever occur. If I turn this up though, we can get some fractional values, and we can actually even go past that if we want to add more rotation as well. It does freak out at a certain point, so I don't recommend this as a technique to add more rotation. But if you're just trying to dampen things down, this is a really cool way of doing it. So anyway, let's set this to 1 for right now. So this is what the simulation's doing. But again, I don't like what this piece is doing, and I don't like this piece either. So what if I went in here and I went to the group and I said, all right, this is going to be the points. I'll just select this guy. And now I have the ability to bring him back down like so. That's really nice to be able to do that, because now I can just have something like that and it looks great. Okay, so we have the animation. Now how are we going to get all of this good stuff over to our main stream where we have the fractured pieces and all that happening? Well, we can't use the name. We have to have an attribute on these pieces and an attribute on these pieces which line up 1 to 1. In other words, I need the same thing for this whole island that's fractured and the same thing for this whole island over here in order for the attributes to transfer properly. So how do we do that? Well, we need an attribute to carry all the way down here to survive the primary, tertiary cleanup stage and make it all the way down here so that we can go ahead and transfer that over. We've already broken up these pieces up here using the assemble into, different areas with the name. So why not just essentially duplicate this data, call it something else, and then shoot it all the way through the network so that when we get down here, we can just reference it and take all this information and scoot it on over. Well, that's exactly what we'll do. So for middle mouse here, we have name, and we actually have name in its full glory right here. So we're going to start our journey right here before anything hits this. And actually, I should take that back. You don't want to do that because the topology changed, the point numbers and all that. So I'll take all that back. We start here at this assemble, okay? And we need to create a point wrangle so that we can basically just say that this will create island ID. So that's what we'll call this anyway. So we'll say that this is a integer. Island ID is equal to at name. Simple as that. Well, you would think. Let's actually call this s at name and s at island so that it's the same data type. Okay, so at first that's not going to work because name starts off as a primitive. So first thing is first, we want this matching up. Awesome. Now on this attribute promotes, we also want to promote this island ID. So I'm just going to pause the video as I go through all of this. I think by now you know enough to go through each one of these things. The main thing is to make sure that it survives every step of the way intact, right? So be sure that anytime you do an attribute promote, anytime that you change something, that island ID survives. And again, we just want that information to travel all the way down here. So rather than watch me do that, because it'll be very tedious, I'll just go ahead and pause the video. All right, and after a bit of tinkering around, we now have the island ID over here on the left. And just to prove that, let's go ahead and unpack these pieces, and I'll also do a visualize SOP. This is a great way, by the way, of checking the attributes. It's also a really good way of rhyming. A great way, by the way. We want to say island ID right there. And remember, we have to unpack that because the packed geometry does not show up properly in the viewport. But we do, in fact, have everything intact, which is great. That's happening over here. And if we look over to the right-hand side, we also have a similar situation happening. If we go before the DOP nets, look at that. Same exact ID on these two pieces. So that all gets carried over like this. And the last part is very simple. We simply take this transform pieces, and instead of using name for that attribute, we say island ID. So now, if we go over here, there's all the fragmented pieces. They now have the animation applied to them. And that's exactly what we want. And after all that hard work, we have something that looks absolutely perfect. Look at that. Beautiful. All right, well, this obviously is not good. I was kidding. I already figured this out. It has to do with the active attribute, and I think that the active attribute's not happy because we're also using animated static objects. The fix is real fast though, so let's check it out. So let's go down here to this DOPNet where we have our main simulation. On the SOP solver, we are triggering active, but for some reason that's causing things to freak out. So instead, we're going to use an alternative called bullet_ignore, and we'll set that equal to 1. So that'll tell bullet to not think about those pieces that fall way down here, and that will achieve the same effect without the freak out happening. So that's simply how you fix that. And after a play blast, we end up with something like this. So things are on the right direction. It's not really coming together quite yet, but we are starting to get somewhere with all this. So let's go ahead and start thinking about how we can make all this better. There are a few things that I'd like to do to get us started with this. For one, it doesn't make sense to really be working on these pieces back here. This takes a lot of our simulation time, and especially when we turn up the resolution on our simulation, we add more booleans and things like that. Not thinking about stuff back here will speed things up very considerably. So what I want to do is reduce the scatter towards the back. And while we're on that same idea, let's also think about how we can prevent these rotations from intersecting the geometry of the temple. So just like we dampened the rotation on that one piece, let's do the same thing. So reduce rotation around the temple. So around temple. So I want to do that. What else? We also have these pieces, these tertiary pieces that are flying up. That's because of a noise that I did, like a pop force, that's pushing it in the Y direction, and I don't like that too much. We will have some of this upwards energy, but we'll take care of it in a different way. So I'll also reduce the pop force on tertiary. And then on top of that, let's also rekey the activation. Now that we have these pieces and we know when they're going upwards, we can rekey when that happens. And also we can slow everything down by about 50% with a time warp. And that will make everything feel much bigger in scale. It's not going to, it's not going to make a huge difference in terms of like the simulation itself, but if we do a time warp on these points as they move, that will make everything feel bigger. So that's a lot of stuff. Let's go ahead and do some of that.